Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem 2144 minimum cost of buying candies with discount. Let's read the problem. A shop is selling candies at a discount. For every two candies sold, the shop gives a third candy for free. The customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the two candies bought. It means that, for example, if there are four candies, let's say one, two, three, four, and the customer buys the candy with cost 2 and 3, then what is the minimum? Minimum of 2 and 3? Minimum of 2 and 3 is 2. So they can take the candy with cost 1 which is lesser than 1. So it is possible that they can candy cost 1 for free, but not the candy with cost 4, because for case 4 it is not holding. So you cannot get this candy free because its cost is greater than the minimum of both candies that you bought. And it is a practical situation where you get free item, those items which has a lesser cost, not greater cost. I hope you got the question. Given a zero indexed integer array cost, where cost I denotes the cost of the ith candy, return the minimum cost of buying all candies. You have to buy all candies with minimum cost. So let's see this test case. Let's see this test case and find the minimum cost that you can spend after buying all candies. First, my question to you is, which candy you cannot buy for free? Which candies you can't buy for free? The answer is last two candies. Last two candies, because if you want to buy any candy, you want to get any candy for free, then it means there is two candy greater than it. In this case, if you want to get four candy, like in this case four, then is there any two candies greater than it? No, no greater candies. So you can't get this four as a free. And if you see 3 also, is there two candies after it? No, there are no greater candies. The greater candies should be of quantity 2. In this case, one candy is greater, that is 4, but it is 1. So 1 is not allowed, only 2 candies should be allowed in the next. Uh, Only 2 candies should be greater than the previous candy. So you can't buy last two candy. You can't get the last two candies as free. You have to buy it by your own money. So this is the major observation for this problem. And my next question to you, which candy you want to buy, you want to get free? So the answer to this question is you want maximum possible maximum possible candy. Like if this is the test case, like 1 2 3 4 5 6, and as I previously explained you that you have to buy this candy and this candy by your own money, so the cost is 11. But next you can get this as free, or you can get this as free, or you can get this as free, because all of these are lesser than the minimum of 5 and 6. So you can buy either of these four choices. So the you want to buy 4, you want to get 4 as free because its cost is greater, very very greater than the 3, 2 and 1. So you prefer 4 as your free item. So this is the major observation, that you want maximum possible candy that is next to the previous two. Next to the previous two, or next or before the previous two you will consider. For this analysis you have to sort the array first. So sorting is very important. And now how can you track, uh, as you can see, the next question arises is, how can you track the free candy that you have not spent any money on this candy? So you can easily track this. If the arrays look like this, and you buy this and this candy, then you got this candy as free. Then these three candies are removed from this array, and next you can't get 4 and 3 as your you can't buy 4 and 3 as your free item, so you have to buy this also. So if you buy this, then you get these two price candy as free. Then you, after this 2 3 4 also gone from the array, then you can't get one as a free, so you have to buy it. So how many buy you perform? 1 plus 3 plus 4 plus 6 plus 7. And where you don't buy any item, 5 and 8, and this 2 you got free. So the major observation is that every third element from the last is you getting free. This is the third element from last, you get it from free. This is the, now this is gone, so this element is now the third last element, so you got it free. So you can easily track free item by count variable. Initially the count variable is 0, and whenever you buy any item you increase your count plus plus, or uh, or buy, or just to go to the next index you will increase your count by 1. And whenever your count is divisible by 3, you simply get that candy as free. I hope you got this. Let's dry run this test case on this code, and this is the final code. That let's dry run it, how the code implement this question through this test case. 1 2 3 4 5 6 7 and 8. This is the array. Our first task is to sort the cost. So if you sort the array, then the array will look like 1 2 3 4 5 6 7 and 8. And after that you initialize your count variable as 0 and spend as 0, and you traverse the array from last element. In this case, since the count is 0 and the last element is present, so you will increment your count by 1. So now the count will be before 0, but now the count will be 1. And since count 1, 1 is not divisible by 3, so you will not continue and spend money on this candy. So the spend variable will get this 8 price. And now the next iteration you will be here, and in this case the count will increase to 2. So 2 is also not divisible by 3, so you will spend money 7 also to buy this candy also. After that you go to the next index, and in this case the count will increases to 3. And if you carefully see, 3 is also divisible by 3, so you will continue because you get this candy as free, so don't need to add the money of this candy to your spend variable. And next time you will be here, and in this case the count will increases to 4. So if the count increases to 4, because 4 is not divisible by 3, so you have to buy this candy. In this case, next time count will be increases to 5 and 5 is not divisible by 3, so you have to buy this candy. Next time count increases to 6 and you have to you don't have to buy this candy because the count is now divisible by 3, so you don't need to add this money to your spend variable, so you go to the next variable next iteration simply, and now the count will increases to 7 and 7 is not divisible by 3, so you simply add that money to your spend variable because you have to buy this candy. And now count is increases to 1 and now count becomes 8 and 8 is also not divisible by 3, so you have to spend money on this candy. So the spend variable now stores the 15 plus 5 20 20 plus 4 24 and 27. You have to spend 27 coins to buy all of the candies. This is the minimum possible answer. So simply you return the spend variable, and this is our final code, and I also dry run this test case on this code so that you can understand this code very well. Thank you for watching my channel. Please like and subscribe my video. Thank you.